Today we're looking at evaluating expressions involving logarithms. Well, what have we been dealing with the past 2 days? We've been dealing with exponential functions. Today we're looking at logarithmic functions. Does anybody know how the two functions are related? Because I thought I hinted at that maybe the first day we were looking at exponential functions. Does anybody know? They are inverses of each other. Exponential functions and logarithmic functions are inverses of each other. So we're going to use that fact today to kind of talk about logarithmic functions and to get those set up for us. All right, so exponential functions are in the form y equals b to the x. What do we call b? It is our base. And what are our restrictions on that base?
Can't be 0 or greater than 0.
It has to be greater than 0 and it cannot be equal to 1. Okay? Now, if there is no vertical shift to my exponential function, what do I know about my y values? If there is no vertical shift, what do I know about my y values of an exponential function? My horizontal asymptote is 0, so what does that tell me about my y values?
Greater than 0.
Say it again.
They're greater
Than 0. Okay? So I know that my y values must be greater than 0. Alright? Are there any restrictions on what x can be? There are no restrictions on what x can be. Okay? Now, why am I going through and talking about what x can be, what y can be, what b needs to be?
Because you don't know how to do it properly.
Because it's an inverse.
And
They're going to use the same stuff.
So
you're close. How's a function related to its inverse? What's going on between the two?
The reciprocal.
What's the relationship between a function and its inverse?
The reverse.
We should know this. What did you say, Christian?
The inverse of the x and the y both switch.
They switch. So what's another term for the x? For x values? The D. Domain. And my y values are called the range. And don't inverses and its function, don't the domain and range switch? Yes, so that's why it's important to know what y can be and what x can be. Alright, so that's why we're going through and defining all that. So if I have an exponential function, what do we need to do to get to the logarithmic function? Find the inverse. Very good, Christian. So what's the first step on finding the inverse?
Flip the x and y.
Switch the x and y. So the first thing we want to do is switch the x and y. We want to switch the x and y. We're headed to getting the logarithmic function. Okay? Notice what did not change. The base does not change, and that's something you need to get in your head. The base of an exponential function and the base of a logarithmic function never change. The base is always the base. That's one of the things we need to take away today is that the base is always the base. It doesn't matter if you're in the log function or if you're in the exponential function, the base is always the base. Alright, once I get here, or once we switched x and y, what was our next thing we tried to do? We solve for y. Okay, and that's where the logarithmic piece comes in. Because right now, there's really no way to get y by itself. And that's where the log comes in. So what we're doing is we're technically taking the log of both sides. And we end up with log base b of x equals y. Okay, so when I get to the point where I have the exponential piece by itself and I want to get y by itself, that's when I use log, or I move log to the other side. Okay? And again, what did I say about the base? The base is always the base. So the base is always in this spot on the log, and it's always in this spot on an exponential function. So once you figure out what the base is, it doesn't matter if you're going from exponential or a logarithm, you always know where that's going to be. It's always got to go in the base spot. So it's very important to identify the base. Okay? So my base is always the base. Now, since my base is always the base, what do I know about b?
B has to be greater than 0.
Has to be greater than 0,
And it can't equal 1.
and it cannot equal 1. Very good. Has to be greater than 0, and it cannot equal 1. What do I know about x?
Does that have to be greater than 0?
Has to be greater than 0. Christian, explain why x.
Because we switched to find the inverse, correct?
Very good. Everybody hear what he's saying? Because we went from a function to its inverse, so what happens to the domain and range? They switch. So whatever y had to be here, that is now what x has to be. Okay? So what do I know about y right here? It can be anything because up here, this x can be anything. So since this x can be anything, that means this y can be anything. Okay? So that's why it's important to know that they're inverses of each other so we can know the restrictions. Okay? So what's something general I can say about b and x, or the parts of a log? What does it have to be? What type of number does it have to be? That has to be positive. Very good, Scott. So anything inside of a log must be positive. That's something that's very easy, and that's something you need to remember. Anything that is inside a log must be positive. If either one of those is negative, you know something's wrong. Okay? So the base and what's inside the log has to be positive. All right, now, when I went from here to here, I want you to notice something about y. What location is the y in? It is in the exponent spot. So that means that this right here represents an exponent. So that means when I work out a log, when I evaluate a log expression, what does the number that it equals represent? It equals the exponent. So that's something we need to get in our head, that a log equals an exponent. Okay? We need to get in our head that if I'm evaluating a log, I'm searching for an exponent value. Okay? So here are some things we need to take away so far. Base is always the base. The base is always the base. So if I'm going from exponential to a log, because eventually here we're going to be switching back and forth, the base is always the base. It does not change. The base always has to be positive, and the base can never equal 1. Cannot equal 1. Both the base and what is inside the log must be positive, and a logarithm always equals the exponent. So I need to keep that straight. All right, so now that we have that set up, we need to go through, let's do an example, and then we're going to go through like 4 properties. So let's say I have log base 3 of 81, and I want to evaluate this. So log base 3 of 81. Can anybody tell me what this is asking me to find? It's asking me to find an exponent. How did I know that, Hunter?
Because
They're trying to find a y, and a log always equals an exponent. That's what I want to hear, is the log always equals the exponent. So, what is it an exponent of? 3, and I want it to equal 81. So, here's how you read this problem. It is asking for what exponent of 3 will turn me into 81. So, what would my answer be? 4. My answer would be 4, because 3 squared is 9, 3 to the third is 27, 3 to the fourth gives me 81. Okay, so that's how you deal with evaluating logarithms. You're looking for an exponent of the base that gives me what's inside. Okay, so now that we've done one of those, we kind of have a rough sense of what's going on. We want to go back through the properties. There are 4 of them. Okay, the first one is I have log with base b of 1, and I want to know what that equals. Now, when I put a b in here, that means it does not matter what this b is, it will always equal this same thing. So what we're saying is if I have log base 2 of 1, or log base 3 of 1, or log base 4 of 1, all of this right here is all going to equal the same number. And does anybody know what that equals?
0.
It equals 0. Okay, Hunter, why does it equal 0? Because anything to the 0 power is 1. And remember, what is the log asking for? It's asking for an exponent. So it's asking what exponent of b gives me the number 1. And it doesn't matter what that base is. If I put an exponent of 0 on that base, what will it always equal? 1. So that's the first property we need to know. Anytime this number right here is 1, my answer will be 0. Okay, that's the first property. Second one. Okay, this right here will always be true no matter what the b is. So what this is saying is, if I have log base 2 of 2, or I have log base 3 of 3, or log base 4 of 4, all of those will always equal the same number. And what will that number be?
1.
That number will be 1. Blake, why is it 1?
Because a number squared is itself. Like 2, or not squared, unless it's squared. But a number to the power of 1 is itself.
Number to the power of 1 is itself. So it's asking 2 to what power gives me 2? And obviously 2 to the first power gives me 2. So anytime these two are the same, my answer will always be 1. Alright, next one. Okay, this one is log base b of b to the a power. So what it's asking is, if I have log base 2 of 2 to the third power, or something like log base 4 of 4 to the fifth power, what would those equal? Okay, so can anybody tell me what this bottom one would equal, log base 4 of 4 to the fifth? Who said that? 5? Why would that equal 5? Okay, because what is it asking? It's asking me 4 to what power gives me 4 to the fifth? And obviously, fifth power gives me that, right? So this one's asking me 2 to what power gives me 2 to the third? So that would be 3. So in general, b to what power gives me b to the eighth?
A.
It would be a.
Okay.
So that's the third one. And the fourth one is similar to that, and it's not going to make much sense to you. But the fourth one is, if I have b, and then in the exponent I have log base b of a, this thing right here equals a. So what that's, if I had numbers in there, if I had 5 to the power of log base 5 of 7, this thing would equal 7. So those are my 4 properties of logarithms that we need to know. Okay? So now we're going to put all that together and evaluate logarithmic expressions real quick. Find my notes. Alright, so next one. I have log base 5 of 5, or log base 5 of the square root of 5. And I want to figure out what that is. Anybody know what my answer is?
1.
It is 1/2. Why is it 1/2? Explain that a little bit better. I'm not very smart.
5 to the 1/2 is going to be the square root of 5.
Okay, so what we need to realize is the square root of 5 is the same thing as 5 to the 1/2 power, correct? So if I replace this with that, I have log base 5 of 5 to the 1/2. We just found one of our properties, or one of our properties said anytime these two are the same, what do I equal?
A.
Whatever the exponent is, so I get a 1/2. Okay, so that's what's going on in that problem. Next one. Okay, log base 7 of 1 over 49.
-2.
-2 is correct. Okay, Kathleen, how'd you come up with -2?
Well, since it's a fraction, I knew it was going to be negative, and then 49 is 7 squared.
Very good. Everybody hear what she said? Okay, here's kind of the way I think about it. The first thing I did was change that 49 to 7 squared. And then as she said, since it was a fraction, that means I need to make it negative. And again, these two match up. Once those two match up, my answer has to be what my exponent is. Okay, very good. Okay, this one is 12 to the power of log base 12 of 4.7. Kendrick, what does this one equal? You don't know? Kurt, what does this one equal? 4.7. Remember, anytime these two match, that's going to be my answer. Anytime your bases match. Okay? Anytime your bases match, whatever the other number in the problem is, that's going to be your answer. And does everybody agree that both of these right here, where are both of those located? In the base spot. And whenever my bases are the same, they kind of cancel each other out. The other number in the problem is your answer. Alright, I have log of 0.001. Hoping you have a question for me. Right. If you notice, there is no base listed. Okay, and as Natasha said, if there is no base listed, it is understood to be 10. So if a base is not listed, the base is actually 10. So if my base is 10, Gage, do you know what my answer is to this one?
No.
No? Matthew, do you know what it is?
It would be 0.01 pound, 0.01.
No?
Three more zeros.
Kurt? Nope.
Negative 4.
Nope. What'd you say? Negative 3 is the correct answer. Bailey, how do you come up with negative 3? Cheating. How can I do this? Say it again. 3 decimal spots. That is correct. Since I went backwards 3 decimal spots, that gives me an exponent of negative 3. Okay? Here's another way. Here's the way I would think about it. What spot is this one in?
That's more than
The 1,000 spot, right? So since it's in the 1,000 spot, that means it can be written as 1 over 1,000. Okay? And then I can change 1,000 to 10 to what power? The third. And if it's like that, then I can write it as 10 to the negative 3. And anytime these match, that means that's my answer. Okay? Several different ways to look at that problem right there. Okay, I have log base 25 of the square root of 5. Log base 25 of the square root of 5. This one's going to be quite a bit different than the ones we've done in the past, or the last few we've done. This one we're not going to be able to do in our head.
You sure?
I'm sure we can't do it in our head.
That's the base.
Or does anybody know what it is?
1/4.
It is 1/4. How'd you get 1/4, Nick?
Because, square root of 25 is 5, and 5 would be 5, so then 1/2 times 1/2 is 1/4.
Exactly.
Say that again.
That makes sense to me. I got nothing to say. Okay, so the square root of 25 is 5, so then that would be 25 to the 1/2, and then the square root of 5 is the square root of 5. Then that would be another 1/2. Then 1/2 times 1/2 is 1/4. So it would be 25 to 1/4.
It's a process.
I'll take your word for it.
That's my brother.
Alright, so here's the way I want you to think. Here's the way, if you can't follow what Nick's saying, here's the way I want you to think about it. Okay? So what is this asking me to find?
The exponent.
Exponent of 25. So I'm going to put y in that spot. So the exponent of 25, that gives me what? The square root of 5. Okay? So I want to rewrite it like that. So the exponent, put a y on my base and set it equal to what's inside the log. After you do that, I want to get the bases the same on both sides. And so what number will I be able to turn both of them into? 5. So over here on the left, 25 is the same thing as 5 squared. So that means I'm now dealing with 5 to the 2y on the left. On the right side, it's the same thing as 5 to the 1/2. So if I got the square root of 5, that's the same thing as 5 to the 1/2. Now, if I have this equal to this, and I have 5 equal to 5, what else has to be true?
2y equals 1/2.
2y has to equal 1/2. And then all I got to do is get y by itself. So I divide by 2, and that gives me the 1/4 that Nick was talking about.
Half of a half.
Okay.
did not understand anything.
So let's try another one that's similar to that.
Nick just said.
I have log base square root of 3 of 27. Log base square root of 3 of 27. So Nick, what's this one going to be?
8 or something. 6, I don't know. I think it's 6.
Say that again.
I think it's 6.
Yeah.
Alright, so let's use my method and let's see what we come up with. So what do we want to do?
13y equals 27.
13 is the square
Alright, hey, we need to get moving. What do I want to do? What's my first step? Square root of 3 to the y power equals 27. Very good. So that's the first thing I want to do. Then what do I want to do?
Make the bases the same.
Make the bases the same. So over here on the left, it turns into 3 to the 1/2 y.
But it's not 1.
And on the right, it turns into
Did you say 4?
3 to the 3rd. So once I get the same base, then what?
1/2y equals 3.
1/2 y equals 3, so that means y equals 6.
Oh, it wasn't.
Oh.
I didn't get that.
I got that immediately.
I don't understand. That's, I don't know how do they do that in their
Because my brother's
I
smarter
can't
than you,
do
that's
that. I
why.
can't do that one in my head either.
I did it in my
I can
head
do the first one.
because
I don't want to do it in your
square
head
root
though. Sky,
What does it? 3 to the what line?
1/2.
of 27 is to the cube.
No.
Square root of 3
Alright, 3 more examples. That should go quick.
So Kathleen, were you saying?
No, I was saying.
Alright, the next thing we need to know or talk about is LN. Does anybody know what LN represents?
Natural log.
Natural log, what does it represent though? What does it mean? Very good. This right here is the same thing as log with base of e. So the natural log is the same thing as log with base of e. Somebody remind me what e is again? Irrational constant. Good. Very nice. So if this is this, what's my answer going to be? What's my answer going to be if I'm asking for the natural log of e to the 5th? What would that equal? That would equal 5. Kai, why does that equal 5?
I don't know.
Carson, why does it equal 5?
Because there's already an E understood in the natural law.
Because this right here is understood to be the same thing as log base e, and then I have e to the 5th, and anytime these two match up, the other number is my answer. Okay? So keep that in mind. Alright, then for the last two, we want to use our calculator. So we want to make sure we can plug in some things into our calculator. So we want to be able to plug these two into our calculator. I want to be able to plug in log base 3 of 635 and the natural log of 35. So I want to do those two in my calculator and then we're done. Log base 3 of, what was it?
635.
635. Log base 3 of 635. So if you notice over here on the left side, you've got log in blue. Since it's in blue, that means I have to do control click. Whoops. I need to press menu first and get the calculator. So control, and there gives me that. Then all I have to do is put 3 in the base spot. put 3 in the base spot, and what was it, 635 over here?
Yep.
Press enter, and it tells me what that log equals. Okay, my other one was the natural log of 35. So the natural log is going to be tied to the E, so I do control, click there, gives me the natural log, I plug in 35, press enter, and it tells me what that equals. So very simple on using your calculator. So that is evaluating expressions involving logarithms. Here is your assignment. Page 178, 2 to 24 even, and you're only using your calculator on 14, 16, and 18. Everything else you need to do without a calculator.
It's easy, but still.